Hello students. So in the previous video, we have seen what is Pythagoras theorem and converse of Pythagoras theorem. So today in this video, let's start the exercise problems. As you can see, the first question, sides of the triangles are given below. Determine which of them are right angle triangles. In case of right triangle, write the length of its hypotenuse. Okay. This question actually in the last video, we had done it, isn't it? So I'll recall this. That is, let's take the first one. The first question is 7 centimeter, comma 24 centimeter, comma 25 centimeter. So we have to take the largest one. The largest one here is 25. Let's square it. So 25 square will become 625. Let's take the other two things. That is 7 centimeter and 24 centimeter. Let's square it and add them. 7 square plus 24 square. So 7 square is 49. 24 square is 576. Therefore, we get 625. So which implies here that 25 square is actually equal to 7 square plus 24 square. So if this condition, the square of the longest side is equal to sum of squares of other two sides, the condition is satisfied. Therefore it is a right triangle, right angled triangle. RT stands for right angled triangle. Okay. Now the right angle is opposite to the longest side. So the longest side is 25 centimeter. The right angle will be opposite to this, and this is the largest one, longest one. So this will be the hypotenuse. Okay. So let's continue with the problems. So the other questions, you can take it as a task and you can try it out. So now let's get into the next question, the second one. Okay. The second question, PQR is a triangle right angled at P. PQR is a triangle right angled at P. M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM into MR. Okay. Now let's do this. First, let's construct a triangle PQR. Let's construct a triangle, right angle triangle PQR. So this is our triangle, right angle triangle PQR. Okay. PQR. Now the right angle is at Q. Let me check the question once again. PQR is a right angle triangle, right angled at P. Okay. I'm sorry, we have to take the right angle at P. So this will be P and this will be Q. Okay. And from P, we have got a perpendicular onto QR like this. So this is the perpendicular PM that is on QR. Okay. Now, what we have to prove is, we have to prove that PM square is equal to QM into MR. Now, if you observe, PM square can be written as PM into PM, isn't it? So QM into MR. So we'll keep one PM on the LHS. We'll send it one more PM to other side. Let's send this to the other side. And let's get QM to the LHS. So it becomes PM by QM. Here it becomes MR by PM. See, if you cross multiply, we get back the same thing, isn't it? So therefore, if we prove this, PM by QM is equal to MR by PM, we'll get the required result. Now, how do we prove this? To prove this, we have to take two triangles. That is, observe the numerator, PM and MR. So which is the triangle that has got PM and MR? It is this triangle, which is in the bottom. This triangle, isn't it? So the one which I shaded now, and the other one, QM and PM. QM and PM is in the above triangle, this one. I'm shading it. So this triangle. So if we prove these two triangles are similar, we will get the required thing. Let me construct it properly. Okay. Yeah. So if we prove this, PM by QM is equal to MR by PM, we are done with the result. Okay. For that, just observe. Let me take a different color. Now, this complete angle at P is 90 degrees. Okay. This is 90 degrees. Let me assume this angle as X. Let me take this angle as X. Okay. Now observe the triangle PMR. One of the angle is 90 degrees here at M. So this angle is X. Therefore, using angle sum property, this will become 90 minus X. Let me write it properly. This will become 90 minus X. Now same thing, the complete angle is 90. Here at R is 90 minus X. So here it will become X. And here it will become 90 minus X. Okay. And all these are using angle sum property. Okay. Now let's take triangle. In triangle QMP and MPR. If you observe carefully, angle Q, that is angle PQM. Angle PQM is actually equal to angle MPR because both are equal to X. And angle QPM is equal to angle MRP because both are 90 minus X. We can also prove one more, that is angle M is equal to angle M because both are 90 degrees. Okay, anyhow, we have proved two angles are equal. Therefore, the triangle QMP is similar to triangle MPR. Let me check it. Angle Q is equal to P, so P comes here. And angle P is equal to R, so it will become R here, PRM. Okay. Let me rewrite it. If you observe, angle Q is equal to angle P. So Q is here, so P will come in the first. Angle M is equal to angle M. Angle P is equal to angle R, PMR. Okay, I'm writing the corresponding equal parts. Okay, so using AA criteria. Now, since two triangles are similar, corresponding sides are in proportion. Therefore, we get QM by PM is equal to MP by PR, MR. MP, I can write it as PM by MR, which is equal to QP by PR. The last one is not required. Let's not take that. Let's take only the first two. QM by PM is equal to PM by MR. So cross multiplying, what do we get? PM into PM is equal to QM into MR. Therefore, we got our result. PM square is equal to QM into MR. Okay, this is how we prove the required result. So the third question is similar to the second question itself. Actually, the first one, AB square is equal to BC into BD and AD square is equal to BD into DC. It is the same thing as in the theorem. Only the thing is the alphabets have changed. You can try it out in the same way. That is, take the smaller triangle ADC that I am shading now and take the bigger triangle ABD. Prove that they are similar. We will get the result. Similarly, take the other triangle that I am shading now differently, that is ABC, and take the bigger triangle ADB. Try to prove it is similar. You will get the third relation. For the second one, we have to do exactly the same as for the second sub question, we have to do exactly the same as the second question. Okay, we will easily get the answers. So this three, I'll leave it as a task. Try it out because it is already done. So let's get into the next question. The next question is, ABC is an isosceles triangle, right angled at C. We have to prove that AB square is equal to 2AC square. Okay, let's do that. What we have got is, we have got an isosceles triangle, right angled at C. Okay, so let's take a triangle. One second. Let me take a triangle. Okay, this is the isosceles triangle, right angled at C. Okay, let me take the other way. This is C, right angled at C, and this is B. Okay, here is the right angle. Now, since it is an isosceles triangle, two sides should be equal, isn't it? So I'll take AC and CB to be equal. We cannot take AC and AB to be equal because AB is hypotenuse. So that is the largest side of the triangle. We cannot have two sides as the largest. We cannot have two sides as the hypotenuse, isn't it? Therefore, AB cannot be equal to any of this. So AC and CB must be equal. Okay. It is not given in the question, but we have to understand that. So in triangle ABC, angle C is equal to 90 degree. Therefore, using Pythagoras theorem, what do we get? We get that AB square is equal to AC square plus CB square. But in place of CB, we can write it as AC itself, because AC is actually equal to CB, isn't it? It's an isosceles triangle. Therefore, AB square is equal to AC square plus AC square is 2AC square. Okay, this is the fourth question. The fifth question is the reverse of this. What we have got is a triangle. Let me draw it. We have got a triangle like this. Okay, we don't know whether it is a right angle triangle or not. Okay, we don't know whether it is a right angle triangle or not. What is given is, they've given that this condition is satisfied. AB square is 2AC square. This condition is satisfied, and they've also given AC is equal to CB. Okay, it's an isosceles triangle. We have to prove it is a right angle triangle. It is actually the reverse of what we have done. So AB square can be written as 2AC square can be written as AC square plus AC square. So AB square is equal to AC square. The other AC can be written as CB, isn't it? Because AC and CB are equal. That's the reason for other one. Therefore, we have got square of the longest side is equal to square of one side is equal to sum of squares of other two sides, which implies angle C is equal to 90 degree. That is, triangle ABC is right angled triangle. It is actually the reverse of the previous one. Okay, we had a right angle triangle. We had to prove AB square is equal to 2AC square. Now it is the reverse one. Okay, let's get into the next question. Sixth one is a very, very important question from the exam point of view. So what we have to prove is, if ABC is an equilateral triangle of side 2A, find each of its altitudes. Okay, let's do that. So let's Draw first an equilateral triangle. Let's say this is an equilateral triangle. Let's name it as A, B, and C. The length is 2A. It's an equilateral triangle, so all the sides are equal. And all the sides are of length 2A. It is given in the question itself. Similarly, AB is also 2A. Okay. Now, if it's an equilateral triangle, we have to find the length of the altitude. Altitude is the perpendicular line drawn from the opposite vertex to any side. Okay. So let me draw the altitude. Let me draw an altitude to BC. If I want to draw altitude to BC from A, we'll draw a perpendicular line like this. Okay. So here is perpendicular. Let me take this as D. Okay. So this is known as altitude. Like this, we have to find the altitude for all the three sides. But since it is an equilateral triangle, finding altitude of one side is enough. Okay. Now, only in an equilateral triangle, if you draw an altitude like this, D will become midpoint. Okay. That is BD and DC value will become equal. In other triangles, this doesn't happen. Okay. Only in equilateral triangle, this will happen. That is D will act as midpoint if you draw an altitude. In normal triangles, other triangles, if you draw altitude like this, D won't become a midpoint. Remember this, a very important point. So if, okay, if this is a midpoint, it doesn't become A by 2, it becomes A. 2A is the length, right? So this becomes A and this also becomes A. Okay, this happens only in equilateral triangle. Okay, now let's take triangle. In triangle ABD, angle D is 90 degree. Using Pythagoras theorem, we can write that. We can write, let me take a different color. We can write AB square is actually equal to AD square plus BD square. AB value is 2A, so 2A the whole square, AD square as it is, BD value is A. So 2A the whole square is 4A square, that is equal to AD square plus A square. Transposing A square to the other side, that is LHS, we get 4A square minus A square is equal to AD square. We get 4A square minus A square is 3A square. 3A square is equal to AD square, which implies AD square is equal to 3A square, or AD is equal to square root of 3A square. So square root of 3, we cannot find it. Let's keep it as it is. Square root of A square is A. Okay. Since 3 and A square are in multiplication like this, I can split the root like this. Root 3 into root A square. But if they are in addition like this, okay, we cannot write it as root 3 plus root A square. This is not possible, okay, using laws of exponents. Only if in multiplication and division we can do that. Okay. So root 3 into A. This is the value of the altitude, okay, of this equilateral triangle. In general, okay, let me write it. In general, altitude of an equilateral triangle, okay, is given by root 3 by 2 into side. This is the formula for altitude of an equilateral triangle. Okay. In this question, what was the side? The side was 2A, isn't it? So 2 gets cancelled. We are left with root 3A. So in general, the formula is root 3 by 2 into side, whatever side it is there in the triangle. Okay, let's get into the next question. Okay, we have to prove that in the 7th question, sum of squares of sides of a rhombus is equal to sum of squares of its diagonal. So there is a rhombus. If we add the squares of the sides, that is sum of squares of the sides is equal to sum of squares of its diagonals. Okay. Now let's do that. For this purpose, let's draw rhombus first. Okay. Consider this to be a rhombus. Let me name it as A, B, C, and D. Basically, what is a rhombus? It is a quadrilateral in which all four sides are equal. Okay, but all four sides, four angles are not 90 degrees. Okay, all four sides are equal. And let's draw the diagonals which is required. So from D to B, I'm sorry. Once again, let me redo it. Just a second. Okay, I've drawn the figure. So it is a ABCD is a rhombus and the diagonals meet or intersect at point O. And the very interesting property is the diagonals bisect each other. That is OA will be equal to OC. Okay, let me put double dash. And OB will be equal to OD. Okay, the length of OB and OD will be equal. The length of OA and OC will be equal because the diagonals bisect each other. Okay, in rhombus, and also the angle at which they meet will be 90 degrees. Okay, the diagonals meet perpendicularly, meaning the angle everywhere will be 90 degrees. Okay, now using this, let's prove the required thing. So what we have to prove is, we have to prove that the sum is addition, the sum of squares of sides of the rhombus, the sum of squares of sides of the rhombus. The sides of the rhombus are AB, BC, CD, DA. Let's square it and add it. So that is AB square plus BC square plus CD square plus DA square. That is equal to sum of squares of diagonals, that is AC square and BD square. Okay, this is what we have to prove. For this, let me take triangle AOB. In triangle AOB, angle O is 90 degree. So using Pythagoras theorem, let me write it as PT. So what do we get? Using Pythagoras theorem, we get AB square is equal to OA square plus OB square. Okay, now I'll replace this OA by AC by 2, because for example, if AC is 12 centimeter, what will be the value of OA? It will be half of it, right? So OA is basically, OA is half of AC, which can be written as AC by 2. Similarly, OB is half of the diagonal, that is half into BD, that can be written as BD by 2. So that's what I'm going to do here. So this OB can be written as BD by 2 the whole square. So AB square is equal to AC square by 4 plus BD square by 4. Now the denominators are same, therefore I can write this as AC square plus BD square the whole divided by 4. Let me transpose 4 to the LHS. It is in division. If it comes inside, it will become multiplication. So it becomes 4 times AB square is equal to AC square plus BD square. If you observe, we have already got the RHS and we have to make a small changes in the LHS. So this 4AB square can be written as AB square 4 times AB square plus AB square plus AB square plus AB square, which is equal to AC square plus BD square. Now will retain one AB square. The other AB square will write it as BC. The other AB will write it as CD. The other AB will write it as DA, because all the four sides are equal, isn't it? So we can do that. Therefore, we have got the result. Sum of the squares of the sides of rhombus is equal to sum of squares of diagonals. Okay, let's get into the next question. Okay, the eighth question. O is a point in the interior of a triangle such that OD is perpendicular to BC, OE is perpendicular to AC, OF is perpendicular to AB. We have to show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus C square. And similarly, the second one, AF square plus BD square plus C square is equal to AE square plus CD square plus BF square. Okay, so let's do it. Even the question seems very lengthy, the steps are very, very easy. Let's start it. I've already taken the figure, and what we have to prove, the first one and second one. I've also written that. Okay. Now, since we need OA square, we have to join O and A. Similarly, we have to join O and B, and similarly, we have to join O and C. So let me join that. Since we need that, so OA is joined, sorry, OB is joined. Similarly, OA and OC. Okay. Let me join it properly. Okay. So I've joined this. Okay. Now, let's take the first one that we have to prove. Now observe, the question itself is our end. See, let's start with the RHS of the first question. The first question, the RHS has got only three terms. What we'll do is, let's find AF square first, then BD square, then C square, then we'll add it, we'll get our RHS. As soon as we get our RHS, automatically we'll get our LHS. Okay. So let's find AF square first. To find AF square, which triangle should we take? We have to take the triangle AOF, because in that triangle, it is a right angle triangle as well as it contains AF. Okay, that is why we are going to take that triangle. So in triangle AOF, angle F is 90 degree. Therefore, using which theorem? Pythagoras theorem, PT. So we get OA square is equal to OF square plus AF square. We need AF square, so let me send that OF to the other side. So OA square minus OF square will be equal to AF square. Let's take it as equation 1. Okay. Similarly, after AF, we have finished AF. Let's find BD square. To find BD square, we must take the triangle BOD, isn't it? Because it's a right angle triangle as well as it contains angle side BD, sorry. So angle D is 90 degree using Pythagoras theorem. So 90 degrees at D, therefore the hypotenuse is OB. So OB square will be equal to OD square plus BD square. We want BD square, so let's send the OD square to the LHS. So it becomes OB square minus OD square is equal to BD square. That will become equation 2. Similarly, let me do the other side. Okay. Let me erase it. Let me do it properly. Let me do it here. We have finished with BD square. Now we want CE square. For that, I'll take triangle COE. In triangle COE, angle E is 90 degree. So using Pythagoras theorem, what do we get? E is 90 degree. Therefore, OC square is equal to OE square plus CE square. We need CE square. So let me send the other side. OC square minus OE square is equal to CE square. This will be our equation 3. What should we do with equation 1, 2, 3? We have to add all the three, isn't it? So let's add equation 1, 2 and 3. How do we add? LHS with LHS. The first LHS is OA square minus OF square. With that, let's add the second LHS, that is OB square minus OD square. With that, let's add the third LHS, that is OC square minus OE square. That will be equal to RHS. So RHS are AF square plus BD square plus CE square. Now, if you observe, let's rearrange this. All the positives first. OA square plus OB square plus OC square minus the negatives. OD square minus OE square minus OF square. That is equal to AF square plus BD square plus E square. Interestingly, we have got the required result. Okay. The required result was OA square plus OB square plus OC square minus OD square minus OE square minus OF square. That is equal to AF square plus BD square plus CE square. We have got the required result for the first one. Now I'll take it as a task. If you observe, we have already found this, isn't it? We have found it here, right? Let's take this as equation 4. We have found it. Okay. Similarly, find AE square, CD square and BF square. Add all those. Okay. The answer that you get will be equal to the equation 4. Therefore, you can tell these two are equal. Or here itself, we can make the arrangements, or we can do some corrections. That is, this OA square minus OE square. If I rearrange this, OA square minus OE square and OB square minus OF square. I'm just rearranging it. That's it. OC square minus OD square. Okay. Is equal to whatever you got here, RHS. Okay. So OA square minus OE square. If you observe the figure in this triangle, OA square minus OE square. Yeah. This triangle, let me shade it. In this triangle, if you use Pythagoras theorem, you will get it as OA square is equal to OE square plus AE square. Therefore, if you send OE the other side, it will become like this. That is OA square minus OE square is AE square. So this first step gives us AE square. Similarly, OB square minus OF square gives us, let me check the figure, OB square minus OF square gives us BF square. Okay, if you use Pythagoras theorem, easily you will get it, BF square. Similarly, OC square minus CD square gives us CE square. Okay, or actually CF square. And we have got this. Okay, you can directly do it like this, or if it's a bit confusing, what you can do is you can find this AE square separately, CD square separately, BF square separately, like what we have done equation 1, 2, 3, and you can add those, all that. You will get the same as the LHS of the first one. So therefore, LHS are same, RHS is same. You can conclude it like that. Okay, let's get into the next question. In the next video, I hope you have understood what I've done in this video. Thank you, students.